Hello life science students, how are you all? I hope everybody is doing fine. Today I will start the saponification, which is the production of soap. It is one of 3 parts to be discussed with you guys. So let's get started here with the introduction to soaps and detergents. Number 1, glycerol. It is a trialcohol of systemic name 1,2,3-propantriol. Propan stands for 3 carbons in the chain as seen right here. Triol indicates that we have 3 hydroxyl groups, and the 1, 2, 3 indicate that the 3 hydroxyl groups are simply located on the first carbon, second carbon, and the third carbon. Number 2, fatty acids. What are fatty acids? They are monocarboxylic acids, which means that they only have 1 carboxylic acid group, which is the COOH, with linear, unbranched, even number of carbons starting from 4 to 22 in the chain. This means that the number of carbons in the fatty acid has got to be an even number starting from 4 to 22 in the chain, and linear means that we don't have any branches attached to the carbon chain. Now fatty acids are classified as saturated or unsaturated. Let's examine the difference between the 2 types of fatty acids. What are saturated fatty acids? These fatty acids have no double bonds across the carbon chain. Only single bonds are found between the carbons in the chain. For example, 12 colon 0. This is lauric acid, and the 12-0 is the representation of lauric acid. Now the 12 indicates that the lauric acid as a fatty acid has 12 carbons, and the 0 indicates that lauric acid is a saturated fatty acid, meaning that it does not have any double bonds across the chain. Only single bonds exist between the 12 carbons in lauric acid. Now, unsaturated fatty acids, on the other hand, they have at least 1 double bond across the carbon chain. For example, oleic acid is represented by 18,1. Now 18 represents the number of carbons found in oleic acid, and 1 indicates that we have 1 double bond between 2 carbons in the oleic acid chain. Now let's look at the representation of the fatty acid. The fatty acid is represented by RCOOH. The COOH is the carboxyl group, which makes it an acid, and the R is an alkyl group. Now, if R applies to CnH2n plus 1, then the fatty acid is saturated. If the R group does not apply to CnH2n plus 1, then the fatty acid is unsaturated. Let's look at these 2 couple examples we have here. We have CH3, CH210, COH. Why is this acid classified as saturated? Now, let's cast aside or put aside the COOH. Looking at the R group, this R group contains, we've got CH210, which means 10 carbons, and you got 1 carbon in the CH3, so the total of carbons here is 11. Now, let's look at the number of H's here. 10 times 2 is 20. 20 plus 3 is 23. Now, if you simply look at this R group, it applies to CnH2n plus 1 simply because the number of carbons is 11. So 11 times 2 is 22, plus 1 is 23. Here we have a 23 H's, therefore this acid is classified as saturated. Now the next example here, we've got C17H33, which represents the R group, and the COH, which is the carboxylic acid group. Now, the C17H33 does not apply to CnH2m plus 1. Therefore, this acid is classified as unsaturated because 17 times 2 is 34, plus 1, it's 35. Since we have 33 for the H, therefore it does not apply to CnH2m plus 1. Therefore, this fatty acid is unsaturated. Number 3, triglycerides or triesters. They are produced by the esterification reaction of 3 fatty acids and the glycerol. Remember, when we discussed esterification reaction earlier this year, we said that the esterification reaction is the reaction between a carboxylic acid and an alcohol producing ester plus water. Now, the same process here is carried out, but instead of having 1 carboxylic acid, we have 3 fatty acids in this case. Remember, the fatty acids, they have the carboxylic acid group, therefore they act as carboxylic acids. And you have 1 molecule of glycerol, so the same process is carried out, but instead of having 1 fatty acid, we have 3 fatty acids here and the glycerol. Remember, when I say fatty acid, you have to simply treat it as if it were a carboxylic acid. So 3RCOOH as seen in this reaction. So those are the 3 fatty acids with 1 molecule of glycerol producing the triglyceride, which is a triester plus 3 molecules of H2O. Now the process or the mechanism of the process, like discussed earlier this year, the carboxylic acid or the fatty acid loses OH. But since you have 3 fatty acids, we have 3 OHs lost by the 3 fatty acids. And from the glycerol, we lose 3 H atoms. So 3 H atoms from the glycerol and 3 OH from the fatty acids, they form 3 molecules of water. And we have the triglyceride as seen in the diagram in front of you. Now, the reverse of that is the hydrolysis. So when you have a triglyceride plus 3 molecules of water, they produce the 3 fatty acids and glycerol. Now the naming of the triester, please. The name of the triester is derived from the fatty acids that are involved in the production of the triester, which means that the name has got to come from the name of the fatty acid involved in the production or that is used up in the production of the triester. For example, here we have glycerol laurate is the triester of lauric acid. So when 3 molecules of lauric acids react with 1 molecule of glycerol, we produce the glycerol laurate plus 3 molecules of water. Now, let's look at the name. Remember, the name of the ester is a compound name, meaning that the name has 2 names involved in the nomenclature or the naming of the ester. Glycerol comes from glycerol and the laurate comes from lauric acid. So when you look at the fatty acid, all we need to do is take the ick out of the word and place instead 8. So glycerol laurate is the triester of lauric acid. Take the ick out of the lauric acid and put 8, therefore it's glycerol laurate. Now, another example. Let's just consider that we have 3 molecules of palmitic acid reacting with 1 molecule of glycerol and to produce the triester. So let's look at the name of this triester. We start with glycerol palmitate. Again, take the ick out of the palmitic acid word. Instead of the ick, put ATE. Therefore, we have glycerol palmitate is the name of the triester produced from the palmitic acid. Now, this is the end of part 1, ladies and gentlemen. Next time, I will have another video, which is part 2 of the saponification. Until then, take care of yourself, and God bless.